Hello everyone. So today let's solve the problem flawed flow. The question itself, the name itself indicates that it is network flow based problem actually. So this was asked in the code forces around 165 for the division 2, rated for the division 2. Yeah. So you can just go through the question. I'll just summarize the question so that it will be easier for us to solve the problem. Yep. Now, let's see what the question states, man, in simple terms. So the input is connected undirected graph. So this is undirected graph, connected undirected graph, right? So the input is connected undirected graph with n vertices. With n vertices, I can just write it in this way: one equals source and n equals sink. So source and sink will be considering, right? One equals source, n equals sink, and m edges, and m edges, and m edges. So this is fine, and m edges. For each undirected edge, for each undirected edge, a comma b, for each undirected edge, a comma b, we are given the flow value c. We are given the flow value c, right? So ci is nothing but the absolute amount of flow along that particular edge, right? So we must orient every edge, right? So we must orient every edge such that there are some certain criteria that they have given or that they have mentioned in the question here. We must orient every edge such that every intermediate edge, right? Every intermediate edge, especially from 2 to n minus 1, we can consider, right? This one. Every intermediate edge from 2 to n minus 1 has incoming sum that is equivalent to outgoing sum. That incoming sum, having incoming sum that is sum that is equivalent to the outgoing sum. Yeah, this is first condition. What is the second criteria here? So second criteria is vertex 1 has no incoming edges. Vertex 1 has no incoming edges. No incoming edges. So this is second criteria. And there is one more criteria actually. The directed graph has the directed graph has no cycle. Directed graph has no cycle. Yeah, the directed graph has no cycle. Just remember this one, right? So producing a valid max flow orientation. It has to produce a valid max flow orientation. A solution always exists. They have said that solution always exists for the input that they have mentioned. Yeah, so this is fine. Yeah, we don't have to mention -1 xyz if it is impossible like that, right? Solution always exists. They have clearly mentioned in the question. This is fine, man. Let me read the question loud. Just listen to this carefully. The input is a connected undirected graph with n vertices. Connected undirected graph with n vertices. One is equivalent to the source and n is equivalent to the this one sink actually, and m edges, and m edges, right? So this is fine, I believe. Next, for each undirected edge a comma b, for each undirected edge a comma b, we are given the flow value c. We are given the flow value c, absolute amount of flow along that particular edge. We must orient every edge so that we must orient every edge so that uh, every intermediate vertex from 2 to n minus 1, this one, every intermediate vertex from 2 to n minus 1 has incoming sum, has incoming sum that is equivalent to the outgoing sum. The second one is vertex 1 has no incoming edges at all. And the third one is the directed graph shouldn't have any cycle, meaning the directed graph has no cycles, right? Producing a valid max flow orientation. It has to produce a valid max flow orientation. So a solution always exists. We don't have to worry about the impossible ones, right? Yeah, this is fine. Let me delete this one. So this is it for the question, man. So let me come to the input output part here. So here, see the first one. So this is nothing but the n they have given, and this is nothing but the m, right? So m or w also you can consider. Wait, actually, m this one actually 10, the value 10 and 5, the last one value in the same row, the last value is 10. So others are adjust basically. We have been given 3 2, so I can just write it in this way, right? This is undirected graph actually. 3 to 2, yeah, I can just write it in this way: 3 to 2, 1 to 2, and this one 3 to 1 actually, with the value 3 to 2 10, and 1 to 2 also 10. Yeah, 3 to 1 it's 5, right? So this is the graph actually. This is the graph actually. Yeah, for the first example that I'm saying, right? The output that I need to get here is 1 0 1, right? So, yep. This is the question along with the input output, right? So we have the this one understanding of the question, input output. Now let's do one thing. Let's quickly discuss the approach followed by the complexities, and then let's write the code. As usual, let's discuss the approach first. So now, uh, so I have went with the same first example that they've given in the question, right? So N, M or W we can consider here. So these are the weights and these are the, this one actually, what do we call? Uh, Edges 3 to 2, this one, 1 to 2 and 3 to 1. The output that we need to get here is 1 to 1. The first thing I want to tell you here is we will be going with the flow propagation, right? So meaning we'll be making use of the BFS along with the Q to solve this particular problem. Let's not go with any of this one complex algorithms. Let's go with the BFS plus Q. That's more than enough actually for this particular problem, right? So we can just solve this one easily. Yeah. Now let's go with the step-by-step explanation, man. I have already shown you the graph actually. This is undirected graph actually with a edges 3 to 2, 1 to 2 as well as the 3 to 1. As per the input actually we are considering the same. See n3 m we have been given 3, edges 3 to 2, 1 to 2 and 3 to 1, right? With the values 10, 10, 5. This is fine. Now let's move on with the idea. Yeah. Now first what shall we do? Let's compute the total incident flow. Total incident flow in the sense sum of f of v for each vertex, right? For the each vertex we will be going with, or we'll be calculating total incident flow sum, right? That is nothing but f of v. So here sum of all C on the edges incident to we will be going with. So for vertex 2 to n minus 1, so this we have discussed. For vertex 2 to n minus 1, the required net outgoing minus incoming is 0. The required net outgoing minus incoming is 0. So that total incident sum for the this one. So intermediate we are calculating right here. This one. The required net outgoing minus incoming is 0. So their total incident sum must be split equally here. Hence, we store f of v to f of v that is equivalent to f of v by 2 for v for the vertex v in 2 to n minus 1, right? So for vertex 1, for the vertex 1, we require no incoming edges. So set f of 1 to 0. For the vertex 1, we require no this one incoming edge for the vertex 1, right? For the vertex 1, we require no incoming edge. So let's set the f of 1 to 0, right? So this is fine. Yeah, easy one. We'll start from the vertex 1, nothing but the source, and we'll apply BFS or BFS along with the Q. Whenever we orient an edge U to V, we subtract that edge C from the remaining required flow f of V. Once f of V becomes 0, then all its incident but unoriented edges can be oriented outwards. Oriented outwards. This point is very important. Yeah. So we will be pushing V to the Q, or so we can push V to Q actually, right? So this is fine. Next, let's try to implement the same thing for the first example, the example that we have considered, right? So the first one, we are considering the incident sum, nothing but the f of 1. We will be going with the edges 2 and 3. So for the edges 2 and 3, we have the values actually 10 and 5 itself. Mm, so just give me a second. For edges 2 and 3, see here, for edges 2 and 3, we are 2 to 3, this one, this is undirected, right? So we will be considering this 2 and 3. This one, we have the value, basically 10 plus 5. So this is fine. One second. Yeah, for edges 2 and 3, it is 10 plus 5. Then we will consider edges 1 and 2. Then we will consider edges 1 and 2. Edges 1 and 2 in the sense, so we will be considering this one. Edges 2 and 3 will be going with this one, right? This one and this one. For edges 1 and 2, so we will be going with this and this again. So this will be 10 plus 10 actually. This will be 10 plus 10. So this will be 10 plus 5, 15, and this will be 10 plus 10, 20. For the edges, this one f of 3, we'll consider edges 1 and 3. Edges 1 and 3, it's similar to same one. This one 10 plus 5, that is equivalent to 15 itself. So first what we will do, we'll set the f of 1 to 0, and we'll set the f of 2 to this one. Accordingly with what we had discussed here, we have to go with this one f of v. See here, for vertex 2 to n minus 1, from 2 we are starting. For vertex 1 we will keep the same thing, right? So we'll keep the same value. The required 2 to n minus 1, the required net going minus incoming is 0. So the total incident sum must be split equally. Hence we store f of v to f of v by 2 for v in 2 to n minus 1, right? So f of 1 we will keep this one as 0 itself, right? So that's the idea basically. Yep. So f of 1 will set this one to 0. F of 2 will be the value is 20, 10 plus 20, 10 plus 10 we got actually for that just 1 and 2. So this one what we'll do, we'll divide by 2. 20 by 2, nothing but 10. F of 3, same thing. For all other things, we'll be dividing by 2 itself, right? F of 3, we got here 15. We will be going with a 15 by 2, nothing but 7.5 will get. We are going with a whole number. So absolute number will be going with a 7 here. So we will start the queue with a 1. We'll start the queue with 1 actually. From 1, we'll orient the edge to nothing but 1 to 2, right? So see the value we have is 10. You can just check. And as 1 to 2 direction equals 0 initially, we'll reduce f of 2 by 10 and, to f of 2 equals 0. Then what we will do accordingly with the idea, we will be pushing 2 to the queue. We'll be pushing 2 to the queue. Also, we will orient 3 this one it's 3 to 1 as well, and we will reduce the value c to 5 actually, since adjacency stores both the directions. You can just check the value there within the graph actually. Since adjacency stores both directions here, it will be marked accordingly, right? It becomes 3 to 1 if the direction set to 1. Next what we'll do, we'll protect this one, we'll process vertex 2. In the sense, we'll handle remaining unoriented edge 3 to 2, c to 10. We'll orient 2 to 3. We'll find the printed directions that matches the acyclic flow, right? So this is fine. Now this yields the output 101, right? So this yields the output 101 because each number indicates whether we use the original a to b or reversed, right? Accordingly with the previous points that we have discussed. So the output that we got here is 101, which is equivalent to the output that they have mentioned for the example 1 within the question, this one, right? Now our approach works absolutely correct here. As we are completely familiar with the approach, let's do one thing. Let's quickly discuss the complexities part. So what will be the time complexity here? The time complexity would lead to big of n plus m, or we can just go with the big of m plus n as well. So m is nothing but the edges here, right? M is nothing but the edges, and building the adjacency list, and every adjacency entry is visited at most once in the queue processing. It would take big of n plus m, right? Overall, or big of m plus n, right? So the time complexity would lead to big of n plus m or m plus n. Now, what will be the space complexity? Space complexity would lead to big of n plus m or m plus n respectively as well, because we'll be going with the adjacency lists and arrays, uh, f directions, basically that requires linear space and the nodes plus edges. This you will get it once we write the code. This is fine. Yep. So the time complexity and the space complexity for the code that we'll be writing in the future would be big of m plus n and big of m plus n respectively. Now, as we are completely familiar with the approach and the complexities, we are good to write the code. Let's start writing the code. Yeah. So let's start writing the code. We'll be making use of the fast input and the output. So let me do one thing. Let me import here. mm, Java.input.output.star. So this is fine. Also, we'll be making use of the different utilities. So let me import java.util.star. So this is also fine. Let me go with a class main actually. Yeah, main. You can just give any class name. You can just give any class name that's relevant to the question, right? So let's go with a edge inner class that stores the adjacency. See, info basically, right? Adjacency information, destination, capacity, as well as the original edge, right? So also we have to go with the reverse, right? That indicates which orientation corresponds to RE. So let's check the same. So I'll just go with the class here. So let me go with the static class edge, right? So I'll just go with the edge here. So let me go with the destination vertex. So this one will be into uh, capacity in CAP. This is fine. So this is nothing but the capacity or the flow value on the particular this one undirected edge. Now let's go with the original edge index. Nothing but, so we are considering from 1 to m. We know this one, right? So this one will be int id, and then let's go with a flag. Nothing but REB, as I've said. So I'll just go with REB. Then let's move on with the constructor part or the initialization part. So this one, let me consider the parameters too. In capacity, what are the things that we considered? ID as well as the, so this one, let me give int. Let me add that here, right? So also, let me go with in REB. So this is fine. Let me go with the initialization. q equals 2. Mm, this dot capacity. Just give this one to capacity. This dot id. Let me initialize this one quickly. And also this dot rev equals rev. This is fine, man. Yeah. Now let's do one thing. We are done with the constructor or the initialization part, right? With the we are done with the actually this one edge class actually. Yeah. Now let's do one thing. Let's move on with the main initialization things. First, let's go with the maximum allowed nodes plus padding. So I'll just go with here static mm, int n equals. Let me go with here 2 followed by 4 zeros 5 based on the constraints actually. So now let's go with the f of v that stores the remaining required incoming flow sum, right? So this one, let me consider the variable f for this. So I'll just go with here static int f equals new int of n. Yeah, this is fine, I believe. Yep. The next step would be let's do one thing. Let's go with a direct this one direction of eid, nothing but it will store 0 or 1, indicating the orientation basically in simple terms. Let me initialize direction dir variable with a variable dir. We'll just initialize this one to new int of size n actually. This is fine. The next step, we need the adjacency list, right? So we have to go with the adjust for the each vertex. So I'll just go with the adjacency, so array list. So let me go with array list here. Let me pass edge. This is fine. Let me consider the variable. We are going with adjacency, right? Adjacency lists actually. I'll just go with new array list. Let me complete the syntax. This is fine. So we have to go with the size, I believe, right? Instead of this one. Yeah, initializing. Yeah, this is fine. Next, let's go with the queue for the BFS like processing. Yeah, so I'll just go with the static here. Let me go with Q as we are making use of the BFS, or as we will be making use of the BFS on the future. This is fine. Q equals new. I'll just go with the array, this one, DQ actually. Yep, this is fine. Now let's go with, let's move on with the further things. Let's go with the helper method added, meaning we have to add the undirected edge to adjacency lists, right? So I'll just go with the static void add edge here, add edge. So this is fine. I need the parameters, this one, node u, node v, nothing but the vertex u, vertex v, int c along with the id, right? So I can just write it in u, C as well as the int id. So this is fine, I believe. So within this add edge method, we have to store one entry for this one u to v edge with a rev0, right? So meaning if we pick that entry, direction of id will be equivalent to 0, right? So I can just write it in this way. We are going with the adjacency list in simple terms. All we have to do is, so I'll just go with add here. So this one will be new edge of, let me pass the parameters v, c, id as well as the 0. Yep. Next, we have to store one more entry for v to u. We did that one to u to v previously. We have to store one more entry for v to u with a rev equals 1. So the same thing, I'll just go with a similar thing, not the same thing. I'll just go with v instead of u dot add here. So this one will be similar. This one, sorry, new edge of this one. I have to pass u, c as well as id instead of 0. Let me give 1 here. We are UC ID and 1. So this is fine. Let me come out of this one entirely. Now we are done with the helper methods. Let's move on with the main part here. Main method. Remove this one, and here let me add throws input output exception. Else we'll be getting the error. This is fine. Let's move on with the this one. Fast input and output, nothing but buffered reader, print writer. Also, let's go with the string tokenizer because we have to read n and m respectively in the question. This is purely related to the input n and m. This one, right? And yeah, we have to pass n and m because they're integers, right? So just give me a second. So I'll just come here. Let me paste this one. This is purely related to the input output part, not the logical part, right? Yeah. So this is nothing but the buffer reader is for the first input, print writer is for the first output, string tokenizer for reading the first line n and m. So we are passing the this one integers, n and m are integers, right? So we have to pass them. So we are passing them. This is fine. Next, let's initialize the adjacency lists for vertices 1 to n. So I'll just go with for loop here. And I equals 1, I less than or equal to n. Sorry. Yeah, this is fine. Let me increment I of I. So this one, let me assign this one to new. Let me go with array list. Yeah, let me go with array list. So this is fine, man. Next thing is we have to mark all the this one. We have to mark all the edge directions as unknown, right? So -1 for the indices 1 to m initially, right? So let's fill this one. I'll just go with the arrays dot fill here. So this one will be direction comma 1 m plus 1, and we are filling this one with a -1, right? So this is fine. The next step, let's read the edge and build the adjacency. Also, along with it, let's accumulate the let's accumulate the incident flow sum. So let's move on with the iteration in simple terms. So this one will be int equals 1, I less than or equal to m, sorry, I. So within the for loop, what we will be doing, so string tokenizer, the same thing. Let me copy from here to here. Yeah. So we have already assigned this one string tokenizer. So let me remove this one. Use the type, right? So this is fine. St equals new string tokenizer of buffer reader dot read line buffer reader this one, right? Variable. So this is fine. Instead of int n m, I'll be making use of this time edges this one, sorry, edge uv, or you can consider nodes u and v respectively along with the c, along with the c. Let me copy this one as again. So this one will be node u, this one will be node v, and this one will be node, not node, basically it's c. C is nothing but the flow amount here. So this is ai that we considered in the approach. This is bi, and this is ci. Ci is nothing but the flow amount, or c we can just consider as c, nothing but the flow amount, right? So integer dot point and string tokenizer dot next token, this remains same. Yeah. Now we have already written added helper method here. This one, let me copy this one and let me make use of it within the main method. Add edge we are using just to add both adjacency records here. So I have to pass the parameters along with it, right? So it is node u v along with it c and I. This is fine. Now we have to accumulate the incident flow for u. So this will be f of u equals f of u plus c. This is fine. And f of v equals f of v plus c. Yep. So these two we are accumulating incident flow for u, and we are also accumulating incident flow for v. We have done that one successfully, right? So let me come out of this one entirely now. Let me come out of this one entirely. Now for the source vertex 1, we require no incoming edges, nothing but we have to set f of 1 to initially 0. So this one we have considered within the approach. First, we have to set f of 1 always to 0, and other things we have to divide by 2. We have to split them equally, right? So that we have considered. Now, for the intermediate vertices from 2 to n minus 1, as discussed in the approach, we required incoming sum equals half their incident sum, right? So because incident sum is equivalent to the incoming plus outgoing, and incoming is equivalent to the outgoing, right? So we have to go with f of I equals f of I by 2, if you remember, right? So we have to start from the vertex 2. So this one, let me move on with the iteration. Int I equals to 2. We have discussed this one in the approach. So this one will be I plus plus. So uh, f of I here, f of I equals f of I by 2. So this is fine, I believe. Next, let's move on with the further things. Let's start processing from the vertex 1. Nothing but vertex 1 is source. In our case, we started from the value 1 itself, right? All the edges incident to 1 must go out from 1 actually, right? So this one, as I've said, we'll be making use of this one, BFS, right? So we are just adding the vertex 1 initially to the queue. Now, let's go with a standardized BFS loop, right? So this one is while of q dot this one Q is not empty actually in simple terms. So let's take the next vertex whose outgoing edges we can fix. So I'll just give here U equals Q dot pull. This is also fine. So let me go with the for loop here. This one edge E C of U. This is fine. Yep. Within the for loop, let's do one thing. Let's write the simple if condition. If this original edge hasn't been oriented yet, so then what we need to do? We have to orient it as U to E dot 2, right? So nothing but to 2 actually. E we have considered the variable, so we will be writing E dot 2. So I can just write it in this way. If mm, direction of this one E dot ID, this is fine. So if it is equivalent to -1, then I'll just give f of e dot 2 here. This one equals f of e dot 2 e dot capacity. So this is also fine. Direction. So I'll just consider e dot id here. Let me assign this one to e dot rev. This is fine. We are just recording the orientation here. This is fine. Next, now if e dot 2 is now balanced, it can emit its what it can emit. Actually, it can emit its outgoing edges next. So we have to just articulate the same thing in the form of code. Let me write one more if condition here. So this one will be if f of e dot 2. So this is fair. If it is equal to 0, then let me go with q dot add of e dot 2. So this is fine. Yep. So let me come out of this one entirely. Let me come out of this one entirely. Now we have to output the orientations for edge 1 to m, right? 0 means AI to BI or A to B. 1 means B to A. So this one we know. Let's articulate the same thing in the form of code. So this one will be int I equals 1, I less than or equal to m. So this will be I plus plus. So this is fine. Next, let's go with out dot println. So this is fine. Next, let's go with the direction of. So this is fine. Yeah. Next, I'll go with out dot flush. Yeah, we have to flush the output, or you can just make use of out dot close as well. Somewhere I did something wrong. What I did wrong, I don't know. Somewhere I have messed up the brackets. So this is fine. Uh, this for loop of b is equal to f of b plus c. F of u equals f of u plus c. This is fine as well. This is fine. This one arrest dot fill. This for loop is also fine. Done. So this one, edge actually. Did I miss anything? Yeah, here I have missed actually. This bracket. So this one I have closed. This edge part also I have closed it here itself. So let's do one thing. Let me cut this one over here and let me paste it. I do this mistake most of the times actually. Right? Whenever I consider this one, consider another class within the class. So I forget to close here itself. Instead, I'll close the bracket at the end. So that will be inside within this class itself, which will quite obviously give the wrong answer. So I'll do this mistake most of the times. Thank God I came to know now itself. Right. So this is fine. Now this is it for the code actually. Before checking the code with the different inputs, let me copy paste the signature starter template. Just give me a second here. Just paste it over here. Let me come here. Let me copy this one. The output that I need to get here is 101. Let's check the same. Mm, have around 8 errors, man. Uh, array list, this is fine. Line number 39. What's wrong here? We have considered that. Oh, this L I have given this one. Small L. Then let me run this one again. One error is cannot find the symbol. And where? Line number 37. Where is it? So this one has to be capital N, not the small n actually. Yep. Now this error has to be gone actually. So many errors. Oh, yet we have 9 errors. Okay. Cannot find the symbol. array list. So again, I have to give the I have to make use of capital L here. Line number 39. This is fine. This one cannot be converted to the array list of edge. Mm, Line number 39. Hmm, What's wrong here? They're considering static array list of edge. So yeah, this one I have to mention array here. I haven't mentioned array at all. So let me run this one. This has to work fine. Yep. So we are left with the three errors. Most of the errors are gone. Now this is warning. Let's ignore this one. Let's come to the error part. Cannot find the, oh, this one has to be capital E actually. Line number 43. Yeah, this has to be capital E. Let me run this one again. This error has to be gone. Two errors. New array list. Again, L has to be capital E. Line number 54. We have one error, nothing but this has to be edge actually. I have misspelled the edge. Line number 75. So let me give G here. This is fine. So let me run this one again. Yeah, we are getting the output 101. Yeah, we have successfully cleared all the bugs. This is fine. Now let me copy this one. We have to get the output 00 110. Let's check the same. 00 110. This is fine, man. Yeah. Let me copy this one. I'll just come to the question. Let me hit the submit code button. This is fine, man. This is E, right? Flawed flow actually. Yeah, let me select the E, last one, and let me hit the submit button. Paste the code and hit the submit button. And I hope this works for all the test cases, man. Let's see. Let's wait for some time. So you can clearly see here the sample test case. I mean, it is showing accepted within the toast, right? So the verdict that we got here is accepted, right? So whatever the code that we have written works flawlessly for all the test cases, works correct for all the test cases in simple terms. This is fine. Now we have went with the this one. Pure BFS along with the queue to solve this particular problem. We don't have to make use of, we can go with this one, Linux algorithm, or we can just go with a push relabel algorithm as well. The number of code, this one, the number of lines will exceed actually, and you have to know the algorithm at any cost, right? So this is one of the simplest methods to solve this particular problem. Accordingly, with the this one, the criteria within the question they have asked, you can just solve this one using BFS with the queue. BFS obviously uses the queue actually. You can just solve this one with the help of BFS, right? So this is one of the simplest methods to solve this particular problem. Yeah, I hope the solution part is completely clear along with the approach and the complexities, right? For now, this is it. Thanks for watching, guys.